Thank you, Flo. So, hi, everybody. I'm really, really excited. I don't know about you, but finally being able to be back in person and here at the Royal Geographical Society, I think it's we couldn't ask for more. So as Flo said, my name is Javier de la Torre, and I'm the founder of CARTO. Again, looking, for the presentations, but definitely for the coffee breaks and all these things. So I hope that, we get time to catch up with a lot of you. But before that, it's obvious, we're at the Royal Geographical Society. I think we couldn't ask for a better venue, right, for this Spatial Data Science Conference. I think this is a great space. I hope you get the time to look around. There's a lot of rooms that, and there's a lot of, maps. It's a really nice place. And if you can, take a picture with Shackleton and Livingstone, which they have a status outside, I think it's a great place. I think it should be very inspiring to all of us. Now, I want to start also by thanking our sponsors for the conference. Well, thanks to all of you. But I also want to highlight, this is the longest list of sponsors that we've got on the Spatial Data Science Conference so far. And it also showcases, a representation of technology providers and data providers. And all of them, or most of them, have booths, so I really recommend you to go and give them a visit, because there's a lot of advancements on the support for geospatial in a lot of these products and these data providers. And I think that speaks a lot towards the interest that geospatial is having as an industry. And so I really recommend you to catch up, because there's a lot of stuff happening in all these products and companies that I'm sure you will be interested in. So, being here at the Royal Geographical Society, I'm a big fan of Stan Openshaw. He's one of my favorite geographers every time. And he was already in 1994, or even before, talking about the concept of computational geography. By the way, I think he was a fellow here at the Royal Geographical Society. And he was already envisioning a world where data was always connected, and it was always being used for modeling, and it was always, kind of like in a dynamic space where everything was computational, kind of continuously happening, right? In large scale and always on, right? And when I kind of read that in 1994, if you read, sentences like this, like it's a appropriate moment to move from dominated GIS towards computational geography. If you read this paper, it really feels like the world that we live in now. So only a few years back, right? But really, if you look at what is happening right now in the analytics industry, the data cloud and cloud native are making really possible this vision of a fully connected geodata cloud, or what they call, a computational geography. And I want to talk a little bit about what this means. So the first thing, just defining the two terms. So cloud native architecture, you likely have seen it on many products. The cloud has been with us for a long time. But we're seeing now a generation of products that are really realizing the power of the cloud with architectures that really benefit from the cloud from the beginning. They were born, with the cloud. They were not adapted to the cloud. And you see them on infrastructure, things like serverless, where you don't need to care about the infrastructure. It's always connected. It's always on demand. Or where you don't have to worry about the scale of the data or the frequency of the data updates. Those are things, that are happening now that, in a way, have always been promised on the cloud, but work quite hard. Now, with all this generation of cloud-native products, this is coming out of the box, and it's coming in an accessible way. That's a very, very important part. The second one is what's so cool, and you might be hearing more, the data cloud. This is a set of products on so-called cloud data warehouses, lakehouses, depending on which products you're using for working with the spatial data. They're essentially kind of like utilizing cloud-native architectures, utilizing the cloud effectively, rethinking the way that we interact with data. And they provide some characteristics that makes it really, really powerful. The first one, obviously, is scalability. So by leveraging the cloud, they can really kind of like scale with the power of cloud computing pretty massively. Second, they're cost effective. The storage, computing separation means that we can now analyze very large amounts of data in an effective way. And also accessibility. With the availability of usage through things like SQL, are making it possible to do analysis at a scale and a cost-effective without having to be like a MapReduce or like a Google or Uber in order to be able to do it. You can just do it like just in a regular database. But to me, the last one, the cloud data search, is probably one of the most important ones. It's what I call a seamless experience to share and consume data. And I'm going to talk more in concrete around this. So these data clouds are essentially enabling this decoupling of the storage and the computation. And it's, in a way, I like to say, making the cloud almost a single database, where we all store our data and we can join it together. So you have different providers, you have your data, and you can do single joins where you're mixing multiple sources without caring about moving them from one place to another. And that is a huge advantage towards breaking silos, where the data from one organization is not connected to others, or breaking the silos between the clouds. This concept of the cloud is a single place, and my data can be joined natively without moving data from one place to another, where we push the analysis and the data stays, is a fundamental part of this data cloud movement. Now, this is great, and the analytics industry have been doing amazing, but how do we apply this to geo, right? I think our goal really is to make geospatial data a primary data type inside the analytics industry. And the good news is that most of these products have already a strong geospatial support. That's why I recommend you, if you haven't looked at them, they've been investing very seriously over the last years, adding geospatial support to them. So there's pretty much geospatial support now in all products, and there's a lot of competition for completeness. Now, the problem is that these products are right now not interoperable when it comes to geo. You cannot export a data set on BigQuery and import it on Databricks and expect the geospatial data to still be accessible. There's no interoperability between them. So that's a really big shame, because in a way, it breaks the position, the vision that we're saying, store the data once and use it from many products. You just can't, because you will not be able to use them with these different products. Now, that's the reason why we've been working over the last year, more or less, on this concept of bringing interoperability between the data clouds. And this realized a couple of months ago with the introduction of a new format, GeoParquet. It's an evolution. It's what we call a community-driven initiative that we've been working on together under the umbrella of the Open Geospatial Consortium, OGC. So many companies, and many of those data providers are now coming together to figure out how we can store spatial data in a standard way that all these products understand, and therefore make them interoperable. For me, it's a huge step. It really it's a much needed component so that we can really realize that vision. And now the same diagram, but think about data from all these different providers and your spatial data, and being able to put them together seamlessly. And this is, obviously in analytics, everybody wants to connect the data to other data, but on geo, most of our analysis always require that we connect our data to someone else's data. So for us, I think this is a huge step that we are taking forward there. Now, there's obviously, Parquet. If you haven't heard around it, you can think of it like the CSV of the big data world, in a way. So it's a format that has been existing for many years now, and it's very good for storing any kind of data. It saves a lot of space and cost on the storage. It increased the performance when using it, and it's right now widely adopted. And I'm going to regret this, but I can say that potentially GeoParquet could be a cloud-native replacement of the save file. I'm going to regret it because I know that under the hood, it doesn't matter what we do, save files will always be with us. It doesn't matter. But you can think of GeoParquet as potentially, that format that could potentially move us, from a file like save file into a file that actually is adaptive for the cloud. That is GeoParquet. I'm happy to see in 5 years how I'm going to be run. But this is only half the story. The other half of the story is around how do you model your spatial data, right? Now that we talk about the infrastructure, great, we just store your data in Parquet, in your Parquets, and you use computing storage and computing engines, etc. Now, how do I structure the data inside? And for that, actually better than actually show you in the slides, I've prepared a demo. This is actually a live demo on a website. I can see it in here, it's full screen. But it is a demo that we've created we've created a synthetic data set simulating a full week of food deliveries in London. We work with a number of last mile companies at CARTO, but obviously that is pretty private data. So what we've done is recreate what it could be a full week of food deliveries, which obviously it's a very large data set because, I mean, there's thousands and thousands of deliveries every day in London, but also because the amount of data that is collected while providing that service, when, like the drivers are moving the data from one place to another, it becomes really, really big. So it is a great example of how really large data sets, can actually, you need to work with very large data sets very quickly in this type of industries. So let's click start. So the first thing here is that you're seeing is just an animation of just the around 10,000 trips that happen every day, right? Now, these companies, the thing that they actually doing is matching what it will be, where the customers are. So this is a map representing all the locations where they have customers, more than, I think in this case, it's around 15,000 customers. And they match it to where the restaurants are. And this is a business, this is an industry where what it matters is, do you have restaurants to serve what people want, or you have, people that want food where, the restaurants are, and so on. So you're matching these two concepts, right? So cover rates of certain type of foods and for certain type of populations is pretty important. So you can imagine how geography matters a lot to these type of companies and the KPIs that they look at it. Now, there's one KPI that probably in this industry matters the most, and it's how fast you're going to get your food. Everybody wants to get their food as quick as possible. So the ETA, the estimated time of arrival of your food, is one of the KPIs that these companies are measuring all the time, right? And that changes a lot depending on how fast the food is produced, is cooked, and how many orders are in the place, how many drivers. There's many things that can change that KPI. And if you look at it, from an aggregated perspective, and this again from our synthetic data set, and different cities tend to produce different average ETAs. Like in London, we found it's 25.5 minutes on average ETA. In Reading, it's 25.7. So it depends on many characteristics. But one of the problems, if you look at it as at the ETA KPI this way, is that you're missing a huge part of the story, which is, okay, is this the same everywhere? Or is there parts in the city where the ETA is consistently performing worse? I mean, are we taking more time in East London, to deliver food? And that's where you have to call, I think, around your geographic support systems. How do you calculate your KPIs in a way that really reflect the way that you can improve them later? So this is the same data, but unaggregated, aggregated by, in this case, a spatial index. So I will talk more about it. And, but essentially, Carl, show us, particular places where it's taking longer on average to deliver the food. So it's a very, very important factor for the company to improve. Or even more, there's another thing that people hate a lot. One thing is that, the food takes a lot of time. The second is that if they tell you it's 25 minutes, but then it takes 40 minutes. The error of the ETA is also a very, very important KPI. And that is something that you can, as a company, can actually improve a lot, because the quality of the ETA depends a lot on the algorithms that you're using for doing that estimation. So on average, you really can improve that a lot. And that is, again, also something that you likely want to see on a geographic support system like this, in a map over different areas, because different areas of the city behave differently. Your algorithms are going to behave differently, has different characteristics, and that's how it's going to help you to actually improve your business. So that's just a quick demo, again, to showcase something that, we, as geographers, we all know, that's, how you model your data matters a lot. It matters because, you're going to be potentially ensuring that you don't lose data, but also because it's going to enable you to do certain analytics that, will derive the insights that you need for your business. So there's this second part, as I said, that you need to consider. How are you going to store your data, and what geographic support system you're going to use to it? And what I mean by a geographic support system, we mean are you going to put your are you going to measure your KPIs by administrative boundaries, by zip codes, by city, or are you going to do a surface, with a spatial index? That's something that you definitely have to think about. And right now, the reality is that the most modern organizations are looking at modeling their spatial data using spatial indexes. So if you haven't looked at it, this is a big shout out, that this is an area that is happening now very quickly, and we see very, very clear. More organizations, more and more, want to treat their geography of their business as a continuous space, not as a set of defined regions, that are potentially arbitrarily. But just as a quick intro, and I'm not going to give a full intro around the spatial indexes, but spatial indexes are different strategies to partition the space that essentially provide you different characteristics, or they help you in different ways. Some of them, you know them very well. Google Maps with their tile system, that's a quad key. There's a classical called like a spatial index. But now more modern approaches, especially for data analytics, are things like H3. So if you haven't heard around it, H3 is probably right now the most popular spatial index for spatial analysis. And why are they so popular? The first thing is that spatial indexes like H3 allows you to parallelize very well on this type of cloud infrastructure that we were talking about. If you think about, like on the left, we have a traditional geometric or geospatial call-like join, the one that you will do working with that geometry, versus in the right, where you're doing it as a join in the database, or in this case on a database, right? By joining the indexes themselves. So those systems tend to be incredibly much faster at the right side of doing things than on the left side. And that's because you're using under the hood something that is the same algebra, is the same call-like systems that relational databases have been working for many, many years. So the whole advantage around relational databases have ended up with systems that are incredibly fast at working at this type of traditional joins. And what we're doing by working with the spatial indexes is transforming a geographic problem into a join like this. That's the kind of like the core secret, if you want to say like that. The second big advantage is that spatial indexes allows you to mix data with other sources much more effectively. If I, as a data provider, as CARTO, you use demographic data, like in this case, population in Italy, if you are mixing that with your own data, and if both data sets are in the same support system, joining them not only is fast, but you don't have to do any transformation. But if I give you the data on zip codes and you have it on other administrative areas, now we're going to have to do a lot of like resampling between them. There's going to end up a lot of errors and potentially a lot of issues around it. So the spatial indexes become like a very fundamental like way to model the data for data sharing in this ecosystem. There's other things like they're just more effective for data visualization too. So obviously they're not affected by depending on the size of the areas because they're uniform. Like it has just simple advantages like that, or much more advantages. Like there's organizations already using them as convolution layers. Like if they were doing image detection on spatial indexes themselves, right? So that's a pretty advanced use case. They're also pretty useful for storing rasters in database. So for me, actually, this is going to bridge the two worlds where we're going to have like vector and raster in the same systems. This is actually one of the ways that this is going to happen. And you can go, this is one of my favorite maps we did it last week. You can also use them even for routing. So we now have a routing engine built on SQL. And one of the things that you can do is create surfaces and use the H3s as navigational call-like units to, in this case, navigate through good weather around the world. So they get to be, you can do a lot of stuff with it. And today, just want to actually announce a big push that we've been doing actually at CARTO to add full support for spatial indexes. So there's a few great announcements. So the first thing is on our analytics toolbox. Our analytics toolbox is a set of UDF or extensions that add further spatial capabilities to these products, to BigQuery, Snowflake, Databricks, and Redshift, which again, the cloud data warehouses of the future. So what you do is you install the CARTO Analytics Toolbox, and it starts with an open source package, and you get now suddenly a set of functions that allows you to work with H3 and quad keys and S2. The three main most important spatial indexes. So you got them straight away on your database. You don't have to use any other library. This allows you to do things like on CARTO Analytics Toolbox, you can do things like isolines and geocoding directly on your database, on your data warehouse, and you can then use them and convert them into spatial indexes. So you see how it's we're introducing an entirely new way of doing spatial computation in spatial indexes just on SQL. Also very important for us, we're adding native support on our Maps API for what we call H3 tiles or spatial indexes tiles. So essentially, instead of sending the geometry of the hexagons, we just send the IDs to the browsers, and then we render them on the client side effectively, and we change, the resolution of the aggregation as you zoom in. It's a very, very important feature because it allows us to explore very, very large spatial data sets stored in spatial indexes. We also have it here, is you're looking at Ukraine, population in Ukraine, part of our data set on demographics at Data Observatory. So we have all these data sets pre-prepared in spatial indexes, and you can now just visualize them natively on those formats. Also very key, finally, we're adding all the support on Builder. Our user interface where you can just write SQL and get maps. Now, actually, it enables you to visualize directly H3 on the browser, again, by using H3 tiles and, and quad key tiles that allows you to visualize these aggregations live from it. So very, very exciting. And that's all I wanted to say today. I think this is a really big change, the way that we think around spatial analysis. There is a lot of advantages that are coming from the generic data analytics world that we have to capitalize on the geospatial world. I think the part around how we model the data is going to be in our hands, but luckily things like H3 and spatial indexes are going to bridge the gap so that we can make geo work much better on just the overall analytics industry. So, and I think that's going to be a game changer for our industry. So thank you very much. See you around.